Hello everyone, how are you all? I hope you all are doing fine. And I'm here again with class 7 physics, and today we'll be doing energy. And before we discuss energy, let us discuss work. Okay, so you all have been doing work, I'm sure at home, your mother, your father, your parents, your guardian, they ask you to do some work, isn't it? So every time you do a work, you apply some energy, right? And you do apply some force also. So before we define work, let us discuss what is work. So every time you lift a tool, you push a sofa, you pick up a pillow, anything that you do, you consider it to be a work, isn't it? And sometimes when you're just standing and suppose your mom asks you to hold a luggage and you just hold the luggage for like 5 minutes and you just keep holding it and you don't move it. And at the end, when you put back the luggage, you think that you have done some work, isn't it? But in science, when you stand still and when there's no movement, then it is not considered to be work done. So how do you define work in science? In science, work is said to be done only when a force applied on an object displaces the object. That means the object has to move. If the object does not move, that means no work is done. For example, if I'm pushing this wall, you push a wall, you push it hard, no matter how hard you try, it will not move. So, though I have applied a lot of force, but still the wall did not move. That's why we say no work is done. Therefore, work in science is defined as if a force applied on an object displaces the object. That means if the object moves. If the object does not move, that means no force, no work is done. Examples: a passenger just lifting his luggage and just standing still, waiting for a taxi or a cab or a coolie, and he or she just stands there for like 10 minutes with his luggage on and does not move at all, then the work in that case is not done. The work done is said to be zero because there is no movement. So if there is no movement, no work is done. And since work done depends upon two factors, one, force, the other one is distance or displacement. So the mathematical expression or the formula for work done is work is equals to force into distance traveled. And the unit of force is Newton, as you know it already, and the unit of distance is meter. So it is supposed to be Newton meter, which is also considered to be joule, named after the scientist James Prescott Joule. So the SI unit of work done is joule, and 1 joule is equal to 1 Newton meter. That means if you write Newton meter or joule, preferably joule. So this is the relation between joule and Newton meter. Now we'll be moving on to numericals related to work done using the formula W equals to F into D. There are some numericals in the textbook also, and I want you all to do it yourself. I have done different sums for you people, so I want you to see here. These are very much similar to the sums given in the textbook. So first see the sums which are given over here, and then do the sums which are there in the textbook, and that would be your homework. The first question here is: a force of 10 Newton when applied to a body displaces it by 5.2 meter. Find the amount of work done. That means force is given and the distance travelled is given. That means the displacement is given. How much is the force given? The force given here is 10 Newton. Displacement is given as 5.2 meter. It can be displacement or distance. And as you know that we discussed in the earlier page that the formula for work done is force into displacement. So just put the values of force and displacement and multiply them. So when you multiply the values, you get it as 52 Newton meter or Joule. So preferably, as I said, we refer it as Joule. So the unit of work done would be Joule. And how do we calculate the work done? We simply have to multiply the force given and the displacement given. So when we multiply that, that will give us the work done, how much work is done. Now, I told you to do some numericals which are exactly the same as work, the one that have been done over here on the board. Now, after the work done, we move on to energy. Now you know energy is that we have everywhere, anywhere you see energy everywhere. It's present here, it's present at your houses, within you, everything that you see around. Now, when you say I am tired, I cannot do work, generally what do you say? You say, I don't have energy, I am tired, isn't it? So every time you have to do some work, you need energy. If you don't have energy, if you don't have enough energy, you cannot do the work. And you get up early in the morning, you feel very energetic, you do some chores, and then at the end of the day, you don't want to do the work, isn't it? You feel that your energy is drained, you get tired, you don't want to do any work. So, energy and work are very much correlated. That means if you have energy, you can do work. And every time you do work, you spend some energy. That's why energy is defined as the capacity to do work. It is defined as the capacity to do work or the ability to do work. That means if you need to do work, if you need to do some work, then you need to have energy. That's why energy is defined as the capacity to do work. Now, as I told you, energy and work are very much correlated. Without energy, we cannot do any work, or to do some work, we need energy. That's why energy and work, they share the same unit. And the SI unit of energy is also Joule. Same as work. So the SI unit of energy and work are Joule. The other units of energy are calories, kilocalories, etc. Or is the CGS unit of energy. Calories we use only for one particular form of energy, that is heat energy. Calories and kilocalories we only use for heat energy. But as you know, heat is also a form of energy. That's why calories also become one of the units of energy. And the relation between calorie and Joule is 1 calorie is equals to 4.184 Joule. Or approximately you can take it as 4.12 Joule. And 1 kilocalorie is equals to 1000 calories, which is equal to 4184 Joule. I hope you understood about energy. If there's any doubt, please feel free to ask. I hope my phone number is given there. So if you have any doubt, you can ask. Now, we move on to the conservation of energy. What is conservation of energy? That means to conserve the energy. There is a law of energy. That means energy can neither be created. You cannot create energy. No one can create energy. Nor can they be destroyed. You cannot destroy energy also. It can only be changed from one form to another. And as we discuss the different forms of energy, you will be understanding it more clearly. That means there are different forms of energy. Energy does not exist in one form. For example, light, heat that you see around you. These are forms of energy. So light can be changed to heat. Heat can also be changed to light. But you cannot say heat energy is over. It is not destroyed. It is only be changed from heat to light. Okay, so we'll be discussing more about it. As of now, just understand this conservation of energy. Energy can neither be created nor can be destroyed, but can only be changed from one form to another. Now, different forms of energy. The different forms of energy, and the first one to begin with is your mechanical energy. Now, mechanical energy. What is mechanical energy? Energy possessed due to motion or position of an object. So, mechanical energy is the energy that you gain when the body is in motion or it is in a certain height or in a certain position. And you'll understand mechanical energy more clearly when we discuss the types of mechanical energy. Now, there are two types of mechanical energy. The first one is kinetic energy. What is kinetic energy? So, kinetic energy is the energy that a body possesses when the body is in motion. That means every time a body moves, it gains kinetic energy. For example, a car moving, a bus moving, or any vehicle moving, or the insects moving, birds flying, anything that is in motion, anything that is moving has kinetic energy. That means when you are in motion, when a body is in motion and the body is moving, which energy does it possess? It possesses kinetic energy. And kinetic energy depends upon two factors. One is mass, the second one is speed or velocity. Now you already know what is speed and velocity, the difference between speed and velocity. We have already discussed this in our previous chapter. So, speed is what? Distance covered in a certain time. How much distance can be covered in a certain time is called speed. And speed in a specified direction, that means when you include direction to the speed, it becomes velocity. So, kinetic energy depends upon two factors. One is mass, the other is velocity. And the expression for kinetic energy, that means the formula of kinetic energy is half. It's half. You might not be seeing it clearly, so you can refer the book. It's half m into v squared. So how do we read it? We read it as half mv squared. M stands for mass, v stands for velocity, and square of the velocity. So the formula is half mv squared. Now how does it depend upon mass and velocity? When the mass increases, the kinetic energy increases. Let me give you an example. An elephant and a rat, if they are moving, if they are in motion, and say if they are moving with the same speed, so which one will have more kinetic energy? It will be the elephant. Why will the elephant have more energy? Because it has more mass. That means more the mass, more will be the kinetic energy. The second factor that it depends upon is speed or velocity. So, that means when the speed increases or when the velocity increases, even the kinetic energy also increases. If cheetah and tiger runs, cheetah is much faster than tiger. So which one will have more kinetic energy? Cheetah. Because the speed of cheetah is much more than tiger. So when the velocity increases, kinetic energy increases. When mass increases, kinetic energy also increases. So you can just assume, you can answer yourself that if a truck and a car, which one will have more kinetic energy? And the answer, I want you to find it out yourself. Now, the second type of mechanical energy that we will be discussing is potential energy. What is potential energy? Energy which is possessed due to the position or certain height. For example, a paint a pen is here lying on the table. A pen is here lying on the table. That means it does not have any, it does not have potential energy right now. But if I lift it up, if I lift this up, that means it has increased its height. It has changed its position. And here, when it comes to a certain height, which energy does it gain? It gains potential energy. A bow, you know, a bow and an arrow. So a bow, when you just hung it, it does not have potential energy. So when it's used, when it is asked to do some work, when you stretch it with an arrow, or when you just stretch it, normally stretch it, which energy does it gain? It gains potential energy because its position has been changed. So a potential energy is the energy possessed due to the position. That means when you lift something up or when you change the position of an object, then the energy possessed by that object is potential energy. And potential energy depends upon mass and height. Now, the same way, mass, how does it depend upon mass? When mass increases, potential energy also increases. For example, I have this marker and this duster. So the mass of the duster is more than the marker. So assuming it, so when I lift this up both at the same height, which one will have more potential energy? The duster, because it has more mass than the marker. Okay, so more the mass, more will be the potential energy. The other factor that the potential energy depends upon is the height. So let's take the same example. I have a duster and a marker. Now, if I lift this up to a higher height and this at a shorter height, since this has more height, since it's at more height than the ground, and compared to this, so this will have more potential energy. That means if the height increases, the potential energy also increases. And the expression for potential energy is mgh. M stands for mass, G stands for acceleration due to gravity that we have done in our previous chapter, and H stands for height. The mass and height can be given. The value of G, every time when we are calculating potential energy, the value of G is already fixed. And you know that because we have done that in previous chapter. The value of G is already fixed. It's either taken as 9.8 meter per second square or 10. So we'll be doing two numericals related with kinetic energy and potential energy. First, we'll be doing a numerical based on kinetic energy. A body of mass 5 kg is moving with a velocity 3 meters per second. Calculate its kinetic energy. Now, first thing you need to write is what are the things that are given. First, mass is given. How much is the mass given? Mass is 5 kg. What is the velocity given? It's 3 meters per second. And what's the expression for kinetic energy? Half mv square. That is half into mass into velocity square. So you just put the values of mass and velocity. So half into, what is the value of mass? 5. What is the value of velocity? 3 square. So kinetic energy is equal to, when you simplify this and put 5 into 9, that's 45 divided by 2. So 45 divided by 2 would be 22.5 joules. So this is how we calculate the kinetic energy. I hope it's clear. If there's any doubt, let me explain you once. Mass is given. The mass is given as 5 kg. Velocity is given as 3 meters per second. Kinetic energy's expression is half mv square. Now you just put the value of mass, which is mass is 5. Velocity is 3. Since we have square, we need to square it. So what's the square of 3? 9. So 3 square, 9 into 5, 45. And 2 is the denominator. So 45 divided by 2 would be 22.5. Now, we'll be calculating the potential energy. A body of mass 5 kg is dropped from a height 25 meter. Find its potential energy. Now the solution here, as I told you, we need to know the formulas and just put the values in the correct order. The mass as given is 5 kg, and I told you the value of G is always fixed. Either you take it as 9.8 or 10. So approximately it's the same. So G is 10 meter per second square. Sometimes the value of G would be given. If not given, you can take it as 9.8 or 10. So G is 10 meter per second square. The height given is 25 meter. And you know the expression of potential energy is mgh. What is the value of m? 5. What is the value of G? 10. And h is 25. So when you multiply them, and there's no denominator, so when you multiply them, you get it as 4250 joules. And please remember, the unit is very, very important. You need to write the correct unit. That is joule. Okay, the unit of energy, SI unit of energy is joule. So your homework would be to do similar sums which are there in the textbook, and I want you to do the checkpoint also. The checkpoint that is there in the book, please refer to that and solve the questions which is based on work and energy. Not the different forms of energy, because we'll be doing the different forms of energy in the next class. For now, you will be doing homework related to work, numericals on work done, kinetic energy and potential energy, and the question answers based on the terms that we have done. And till we meet again, so till then, stay safe, stay home and stay happy. Thank you.